Hello guys, this is John. In this video series we're going to learn Haskell through building a small roguelike. Why building a roguelike? Well, in my career as a programmer I had to learn quite a few different programming languages, and I found for myself a very simple and easy way and a fun way to do that is to try to build a roguelike. So let's begin. I'm gonna put some background music for myself. I hope it's not so loud that you guys can't hear me. As you can see, my workspace is set up, although it's very empty. I named the project Helda for Haskell Zelda, which is very innovative. We're gonna go with Cabal for this one. The alternative, of course, being Stack. No, wrong. Good. Okay, so what I will try is not to talk too much, except when I have to explain what I'm doing. Mostly because I don't really like the sound of my voice. But I'll stop every now and then and try to walk you through my thinking process and my design choices. And of course, you're welcome to comment, provide alternatives, or troll. Okay, so a game is a simulation that runs continuously until it stops. It takes an input, it takes an old state, and it produces a new state. The secondary process is the one that takes this produced state and creates a frame buffer out of it and displays it on the screen. For start, let's focus on the initial part. So we need an initial state, which we can simply hard code, and we need a way to retrieve input, which obviously we could hard code as well, but then it wouldn't be a game anymore because it wouldn't be an interactive piece of software. We're gonna need a library to fetch the inputs, and because we're gonna be doing a roguelike and rendering everything in ASCII, we're just gonna go with ncurses. Now, I don't totally remember what's the name of the library, so let's just try and find it. Package ncurses. Great. That's exactly what we need. That's interesting. Ncurses are already installed. They should not be. We just created this project. They're here. Good. So my favorite way of starting to define a roguelike is through defining what kind of interaction I can have with this game. And here, there's two ways to do it. We can do it through specifying a type class that would serve as our DSL, but I'm not entirely sure how would I make an input DSL. It would probably be something very simplistic. The other way is to just define your data types, and I'm gonna opt for that one right now. So, our interactions, let's call it input. We're gonna be able to move to somewhere. Attack. Close. Should we add get, obviously. Oh, talk. See, what I'm thinking now is this. I want to be able to lock the values for direction in which we can move. The alternative to writing direction is we could use a vector of ints, right? But the problem is this vector could contain many more values as a solution to construct a very valid instance of input. What I want is to narrow that to a small amount of values. And if I just put this 4, it means that we can just move north, south, east and west, and we get to hardcode the speed, which is obviously one tile. But then again, I feel this is just a bit too verbose. And I'm thinking if I can just do this using a new type. Basically, we do this. And then in here we're gonna create and then we have smart constructors. Time for some more convenience pragmas. If I lock this out into a separate module and don't export the constructor, but export the get vector, I'm gonna be able to construct only these 4 values and have the vector for free. So let's do that. We need linear, which is Edward Kmet's excellent linear algebra library, but we need to add it. Yeah, sure. we're in a sandbox anyway, so. And that's why I should have used stack and not cabal, because stack would fix these version issues for me. Right, while this installs, let's go and check up how do we get an input. Yeah. Okay. Get event passing window. Turn cursors on the event. Okay. Okay, so we start with this, and then we're gonna just ask for the default window to begin with. Sure. Actually, it's not IO, it's a curses thing, is it? Yeah, okay. Okay, so what did I do here? I'm guaranteeing I'm gonna return an input, and right here, this says that the input might be maybe. So it might not return one. But the thing is, this function also takes this parameter here that is a timeout. So if the timeout expires and there's no event, then we're gonna get a nothing constructor here. Quite the opposite, if we pass nothing here, it means we want to lock, as it says here, until an event is received. So we know for sure that this maybe is always gonna contain a just value. So what we're gonna do, we're gonna use a partial function that's gonna make sure that we encode the value out of maybe. And yes, we're gonna need import data maybe from just. I think my auto-completion is blocking because it's compiling new libraries down here. Okay, so get event. There's gonna be some window, nothing, and we're gonna return from just bingo. You know what? Let's just let's just say we're gonna be using default window for our events. So right here. How do I want to do this? I keep hitting that control space all the time. Wake up. Default window. Map into here. There you go. And then let's see if we can make this better. If we add backticks and this on this side, and we do this, and this can disappear. That's good enough. And then from just goes here. Pretty good. Actually, this returns. What we need to do is also encode the event. So C event to input. And right here, the results, or I think that's properly called the range of our function, are all possible combinations of, well, all possible constructors that we can create for the inputs. And the good thing is if our range is small, it means that our domain, which is the input, can be small as well. Oops. So we know we can create only 4 types of directional values: east and west. Look at this little error here. Okay. We're gonna pattern match on the curses event that we extracted from that maybe right here. This is finally done. Okay, let's check how their events look like. So we have character, special key. We don't care about mouse, don't care about resize for now. No idea what is that. What are keys? All right, these are all the keys on a keyboard that cannot be expressed as a character. Sure. Right now we just need this. So let's character. Please wake up. Vim keys, north is K, south is J, east is, no, that's east is L, west is H. We're gonna attack F, open with O, close with C, get with G, and talk with T. There you go. A complete function. Test. Okay, so what I'm gonna do, I'm gonna make sure I can actually build from inside Vim. And the reason why is because I can get all the errors in their message window. Thank you. Oh, this is terrible. What the hell am I doing here? Okay, yeah. We need to fix this much better. Right. That was incredibly stupidly written. I don't even know how did I not realize, but okay, I want to make this a bit prettier. Let's see. If we do this, and we compose. I want to say kinda. Sure. So so we can't run get input because it runs inside the curses. But what we can do run curses, right? Good. So we're gonna run curses, and our curses is gonna be get inputs, and this should block until we press one of the keys. Okay. Let's see if we can get something out. No? Bingo. There's one problem though that I can see. Because our domain of the function is so much larger than our range, we are not handling all possible input cases here. Like, for example, what happens if I press any of the letters that are not in the list, like I, and kaboom. So we need to handle a case for all other events. And what do we do here? And now, this is an interesting question. We could do this and add an idling action here that just passes the time. But in general, in roguelikes, this is handled by the dot key. My thinking is that if you don't enter a valid input, you should just skip it and wait until you get something new. You don't move forward because, as we stated before, a game is a simulation that takes an input and an old state and produces a new state. If you don't have an input, there's no need to run the simulation. So what we're gonna do, we're gonna convert this to actually add idling. Right. And right here we want to signal that we did not receive a valid input. There's two ways of doing this. One way is we enrich our data type to have a constructor saying invalid or something. Or we could lift our whole result into a functor, and that's exactly what we're gonna do. We're gonna use everybody's favorite sum type, a maybe. And then right here, if our result is nothing, we want to rerun the function until something comes out. Yeah, sure, why not? Let R in if this is ugly. I'm not happy with this. How it's gonna be written, so let's figure out something better. Let's do this. Oh. Maybe inputs. And this gets maybe inputs. Yes. Right here we're gonna go for bool. And we can f map. No, because we're gonna run another function with effects in case it fails. So we're gonna push this forward. And then this is gonna be our inputs, which could be nothing. Could be nothing, or it could be just, and we're gonna add additional quality of life, pragma, case, lambdas, no, lambda case, bingo, case, in case of just input, we're gonna return input. You know what? Let's play like this. And if it's nothing, keep running. Let's see how that works. I'm pressing I. No, I pressed I. O. R. T. Q, W, E, R, A, and F. I like this. Okay, we're about half an hour in. I think this should be enough for the first episode. It's a bit slower than I thought, but it's okay. You will find the link to the GitHub where this project is going to evolve in the description, and I'll see you in the next episode, where I hope we're gonna get to tackle actually creating the base simulation. Have a good one.